Okay, welcome to this lesson here. We're going to be taking a look at lesson number 1 on volume of pyramids and cones. And specifically, we're going to take a look at the volume of a pyramid. Okay, and I'm going to do a comparison of how we can use prisms and pyramids as a comparison. And so I have a little video that we're going to go through. Let's just remember here, we have our pyramid. For volume, we need the base, whatever that happens to be, in this case a rectangle, and we need the height, which is from the base up to the apex, and again, that's at a 90-degree angle for that. So let's do a little comparison here, and I'm hoping that it's going to work out. I'm just going to pause that one because I'm going to talk over it. For this one here, we're going to be comparing, like you can see, a pyramid and a rectangular prism. You'll notice that I think I show this very soon. I'm just going to again talk over it. That these happen to be the exact same size. Okay, in many ways, they are the same height. There, you can see that they're the same height, and they have the exact same base. So those green parts are interchangeable. If I take that one out there, take the pyramid one out, it fits exactly in there. So they have the same base, same height. That's our comparison. Now what we're going to do is we're going to compare the volumes of the pyramid and the rectangular prism. I'm going to put some water into the pyramid and see how many volumes of the pyramid fit into the one rectangular prism. So we're starting with 1 there, and it's not too bad. You can kind of see it. Good. There, you see me twice in 2 different places. There we go. It's all filled, and I'm going to dump it into the prism. And you'll notice that the prism is not full. Okay, it's actually, it looks like just under half. So we can probably put more than 1 pyramid in. All right, so now I'm kind of talking about a few things there as well. I'm going to try another one. All right, fill it all up. There we go, right to the top again. Okay, there's actually a line on top I fill it up to, and we dump it in there. And again, not full yet. We still have some more space. Now the question is, can we put a third one into there? Let's try. So we're going to take that, we're going to dump it in. Let's see. And sure enough, it is perfectly full. So what we can deduce from this here is that the prism is 3 times bigger than the pyramid. And so if we know the volume of the prism, we can find the pyramid by dividing it by 3. All right, so let's see if we can come up with, there we go, all done. Okay, and yeah, I walk away. Kind of a fun little part of the video. So how we're going to find the general formula of a pyramid? Well, we're going to take the prism one, which was base area times height. And instead of that, we're going to just divide it by 3, and that is our general formula. Okay, so that's our general formula. It works every time. For a pyramid, we take the base area times the height, which is what we did for a prism, and then just divide it by 3, and that's going to give us the volume of a pyramid, which has the same base and height as that prism. All right, so let's do a few examples here. I am going to just move myself over. Yep, I can do that. Woo. Hoping that all works. Make myself a little bigger even too. Here's your first question. So with a partner or at your table, grab a piece of paper, solve for the area of this prism, okay, using our formula that we have. Pause the video now and come back when you have your answer. All right, hope you came up with your answer. Let's figure out the volume. Now, what you might notice is that I didn't give you dimensions of the base. Yeah, it's a triangle, but I've just given you an area. But I've also given you the length of this prism, so we can solve for it. Remember that our formula is base area times length. The base area is already given, it's 35. We're multiplying it by the length, and we get a volume of 455 cubic yards. There we go. We didn't even need to know the dimensions of the base. All we had to know was the area of the base. All right, now let's do the same thing, but now we're going to do a pyramid. So I've given you the base area of this pyramid at 148 square feet, and the height to be 10 feet. What is the volume? Pause, find your answer, come back when you have your answer. Okay, so the volume of a pyramid, base area times height, but now we got to divide it by 3. So take the base area, 148, multiply it by the height of 10, divide that all by 3, and hopefully you got 493.33 cubic feet. Did you get it? Yeah? I'm hoping so. Okay. So again, it's base area times height divided by 3. Now, what we're more going to typically see is something that looks like this. You're given dimensions for the base, and now you'll have to figure out what the area of the base is, multiply by the height, divide by 3. Pause the video, come back when you have your answer. All right, our regular formula is this right here. Base area times height divided by 3. This is a rectangular prism, so we're going to do length times width as our base right there, multiplied by the height. Kind of looks like a rectangular prism, right? Yeah. Okay, but it's a pyramid, so we got to divide by 3, plug all of our values in, divide by 3, and hopefully you got 160 cubic inches. All right, so far so good. Okay, let's try a little bit different. We have a hexagonal, there we go, yeah, 6-sided shape. We've got a hexagonal pyramid. If you can't read that there, it's 5 yards on the base, 4.33 yards on the apothem, and 20 yards on the height. Pause the video, come up with your answer, and we'll see how you compare to mine. All right, formula is always base area times height divided by 3. The base is a hexagon, so we're going to use our polygon formula right there. Plug our values in, 5, 4.33, and 6 happens to be our number of sides, and then 20 is our height. When we find that, we get 433 cubic yards. Hopefully you were able to do that without too much help. Okay, I'm hoping so. Again, maybe it's a little tougher if you didn't get the right numbers in there. That's okay, but as long as you know how to do it, the questions will look a little bit clearer, hopefully, on your assignment. All right, here's the next one. What is the volume of this square-based pyramid? Pause the video, come up with your answer, and then we'll come back when you're done. All right, let's take a look. We want to try to figure out the volume, so we need the height. We're not given the height, we're given the slant height. So we're going to remember that there's that little right angle triangle. We're given the height. We can know what half the base length is, so we're going to use our Pythagorean theorem and come up with our height. In this case, it's A, because we're going backwards, and we get a height of 11.62 feet. It should always be less than the slant height. Should always. Okay, if it's not, then you might have done something wrong. Make sure you're subtracting, not adding. Base area times height divided by 3. Our base is a square. Therefore, our volume is 139.43 cubic feet. Okay, so the tricky part is you got to find the height. All right, let's try this one. We have a word problem. So we have a square pyramid that has a base length of 17 meters, a height of 16.5 meters. We want to determine what is the volume of the pyramid. Pause the video, come up with your answer, and unpause when you're ready. All right, let's see how we did. Volume, base area times height divided by 3. The base is a square, so we're going to do base squared, or the base length squared, and plug that in and get a volume of 1,589.5 cubic meters. All right, how are we feeling? Yeah, ready to go? Thumbs up, thumbs down, middle-ish. Okay. All right, work on your assignment. There's going to be a few questions that are going to be assigned today. And if you have questions, ask neighbors, see if you can find what the answer is. If you can't, when I'm back, I can try to help you with the answers to that as well. Thanks for watching. Have a great rest of the day.